So the problem so far is that I don't know if I have enough snacks to get through SuperStream Sunday. So, I mean, I am going to take breaks between streams. So at some point, there may be a snack run break. That's all I'm saying. Okay, someone's asking about the linker. No, it's a misunderstanding. So we are not ever going to implement a linker that's a linker in the classical sense of something that replaces link.exe or whatever. What we are going to do is make a compilation path that does not require linking, because linking is stupid. I mean, the way it's conceived and executed now is stupid. So, you know, what's going to happen is for the for all native code, we will not require a linker at all. For, you know, sometimes you need to link libraries that were written in C or something, right? And for those, hopefully for fast builds, like for debug builds, we'll just eject or inject some pre-main code that will like dynamically load those on startup, because for some reason that's way faster than linking when in fact it should be way slower. So that'll be thing number one. And then, you know, for release builds, if you're linking in libraries written in C or something, you're going to have to eat the cost of running a linker, but we'll ship with like LLD or something. Something that we're allowed to redistribute. So yeah, we don't plan to write our own linker in the classical sense, because that's a giant rat hole of annoying wasted time, but we plan not to need one. Which game genre is harder to make, in my opinion? FPS by far. Yeah, it wasn't stupid back when computers had memory in hundreds of bytes. That is true. But that is not the world we find ourselves in today. Do I find I can be more productive having multiple projects I work on rather than a single one? Yeah, I think my optimal is 2 projects, where one is the main one and one is kind of the side one that I toy around with. Right now I have more than that happening, which is not optimal. But for me, 2 is optimal. But one of them has to be smaller than the other. Like, one of them has to have most of my attention and be the serious one, because it's just too hard to make things to have more than one. Do I think Vulkan is worth it? I don't know. I've never used it. I've heard bad things, though. Any special reason why FPS are more difficult? Because the graphics is a lot harder. Because a first-person view requires graphics to be much higher fidelity. It requires collision detection to be much higher fidelity. A viewpoint that extends out over a landscape for a long way tends to have a lot more things in the view volume that you need to render efficiently. Whereas something like an RTS or something like that, you're looking down on a scene and it's very limited how much is within the camera. And then also there's the fact that FPS is traditionally competed on visuals, and so you have to compete with very good visuals, which is not true in most other genres. Can I make the face cam a little bigger? Why? One of the things that Go does is to not link any system stuff and just call it a runtime, so even normal Go doesn't need a linker in that sense, even if the normal Go linker is a weird thing that isn't really a true linker. Yeah, so that sounds like that's something like what I'm talking about as well. It's just like we have to get away from this 1960s compilation model / 1970s. And you know, if you glue yourself to it forever, you'll find it to be limiting. So that's the agenda, is to get away from that stuff. What is my favorite game from the 8-bit, 16-bit era? I mean, the games haven't aged well. Most of them that I remember really enjoying, I go back and try to play them now, and I'm like, yeah, this is actually a terrible game. And that's a good sign, though. That means that games have legitimately gotten a lot better. I mean, probably the Infocom text adventure Trinity is my favorite game from those days, but it's hard to tell. What is the to-do list for today? Well, it's a little bit loose. I'm going to start out working on more compiler bugs because there's just some on the list. But I want to also do either progress on a compiler feature or a new, like I have an idea for an application program to work on a little bit. I don't know. Like, you know, we could start making the libraries thing more formal today. I don't know. We'll see. We'll see where it goes. Do I have an opinion on the Larrabee architecture? I don't know anything about the Larrabee architecture. Is it possible to open the editor in the witness, or was that removed in the release build? It is removed in the release build. We don't compile it into the executable in release. Can I please make a custom native Slack Discord client? No, but someone could do that. What is my opinion on the Spectre Meltdown on Intel CPUs? Those are two different things. Spectre and Meltdown are two variants of similar ideas. I don't know. I know basically what they are, but I haven't formed an opinion on how serious they are. It doesn't seem very serious for games to me, except to the extent that you might be doing cryptographic things inside your game or microtransactions involving money. We might do some Sokoban programming today. We might. I'm not in Seattle today. I'm in San Francisco. Will there be a donation option? Yeah, probably. I'd like to fund work on it in some way, like maybe we do like a Patreon or something. I would need to find some way to make that work, like to bring in enough money to make it worthwhile. Maybe we need to be like Star Citizen and sell spaceships that don't exist inside the compiler, and you can buy your spaceship. I don't know. The compiler links to LLVM via the API, yes. So we call the LLVM API. I tried producing IR directly in my first attempt, and it was just, I was trying to produce it in textual format, and it's just a bad idea because it's just not set up to work that way, and it's very easy to generate something that's invalid and with no debugging help to tell you exactly what's invalid about it. So using the API is sort of the right way to do it. Will the compiler be released on Linux? Yes, it will. All right. Let's see what's on the debug list for bugs. Debugging bug list. All right. Bug 72, bug 78. And then this other stuff. Expressions with casts are not considered constant. Oh, what a pain in the ass. Although maybe not. Maybe that one can be worked out. Oh, there's a problem with that one, actually. Evaluate type of compile time. This one's weird. Like this should totally work. I don't know what the problem is with this one. We'll look at it. Let's remind ourselves what bug 72 and bug 78 are. Those are there because I wanted to skip them because they're too annoying. So let's go debug. Oh, this one. All right. Let's take a look at that. This one involves a policy decision, so it's not just a bug fix. It's kind of interesting. So here's what's going on. Ignacio's doing a direct 3D interface. So, you know, I did a rudimentary OpenGL interface before, but maybe you want to use direct 3D instead of OpenGL. So, yeah. Now, so in doing that, he's implementing the whole COM thing that Windows does sometimes, right? And so you have this like IUnknown situation. Now, he has this device vtable that's got this stuff and then more members that we don't need. And this is the right way to do it. You say, hey, there's something called base, and it's an IUnknown vtable, and we're using that so we pull down the members. Now, the problem is he accidentally did this. So he just said using IUnknown vtable without the base. Let's go to Windows. So here's IUnknown vtable. It's just some procedure pointers. It's, you know, there's nothing surprising there. So the thing is, when you do that, you want to be able to, using a struct or enum type, or a namespace when we have namespaces that aren't structs, because, I mean, you want to pull in all those symbols and stuff. The thing is, these don't have storage because no storage was declared for them. But it's not generating an error. So I need to do one of two things. I need to either make this valid and just say, hey, we're putting storage here, right? Or I need to give an error and say, hey, you need to do this second version. Yes, it's the IUnknowns battlegrounds. Unfortunately, that's what we're faced with. Let's rebuild to make sure we can run our c.exe. I did reboot since yesterday. Look how slow this is. It's using all the cores on my machine. Oh, nope. All right, well, Visual Studio 2017 it is. I guess Visual Studio 2017 breaks Visual Studio 2015. That's what happens. So I just might as well uninstall 2015. I don't know. Let's rebuild it here. Good thing we get to start off with SuperStream Sunday with our compiler tools not working. I mean, that's another just reason why this whole thing about tool chains consisting of many different programs and libraries is a bad idea, right? If my compiler was one program, I wouldn't have that problem. It wouldn't fail to run another program because it wouldn't need to run another program. it's like this whole culture of adding points of failure to your system because you think it's a good idea. It just doesn't make any sense to me. Could be a Windows SDK version issue in project properties. Maybe, but if that's true, it happened when Visual Studio 2017 upgraded my project file or whatever. "2015 might be rough to uninstall." Yeah, well, we'll see. The known I unknowns and the unknown I knowns. Okay, I dig it. Okay, so oh. Okay. Will I consider supporting work on a language server implementation? Probably not. I mean, if someone wants to do that, that's fine, but I'm not going to pay for it. I think it's the worst idea ever. For the same reason that I was just unable to run rc.exe, I think, well, and many more reasons involving computer efficiency, I think the language server idea is one of the worst ideas ever. And I think the fact that it doesn't receive more criticism is a sign of how far programming culture has fallen in the past 20 years. Assisting? I mean, nah, I don't know. I mean, I'm frankly not that interested. I mean, we'll definitely be providing lots of example code that writes out information from a program in a meaningful way, right? That's exactly the information you would want the language server to know about, right? We'll provide like a very plug-and-play thing for that. But in terms of me personally spending my time giving advice on how to implement a language server, I just got too many other things to do, man. Too many other things to do. All right. Like one of those other things I have to do is make this decision about how the hell do we solve this. So I want to make this decision in the context of future libraries as well. So if you say using whatever, you could be using a namespace that has global storage. Space that has global storage. You could be using a struct that has only constant members. I think I'm, for now, just going to check for this case and report a helpful error message if we see it. And then when we do further work on the libraries, it'll become naturally more obvious whether we want to support this. So what we need to do is when we're using a type that has no storage in this form, we just need to make an error if there's storage. It doesn't seem hard. We'll find out. So why doesn't the plain using version have no storage? It does have no storage. Is that using foo the same as something like using underscore colon foo? Well, it could be, but it's not right now. And I'm not sure if that's the right thing or not. So the thing is, either way, so whether I want to do the using underscore colon foo or not, I at least need to detect the case, right, so that the compiler knows when it's happening. So what I'm going to do is detect the case, right, that's the main piece of this work, and then I'll report an error right now. And if later when we detect that case, we want it to actually make a variable, then we could do that. I just, you know, my general policy decision is I don't want to add a lot of hidden magic to this language unless you really get a great deal of utility out of it, right? Because every little magical thing that you add like that slightly decreases clarity of understanding of what's happening. In many cases it does anyway. And so I only want to pay in clarity when I really get something back. All right, so it's going to take me a while to figure this out probably. I have this thing called phase 3. It's really phase 2. This is when I go through and add each declaration, right? So we have a source scope and a target scope and so forth, right? Now, this probably, and you know, you can pass the name remapper. Well, not yet. You will be able to. Oh, that's a thing that we could do today, by the way. Let me, before we go on, I'm going to start making a list of things to do because it's SuperStream Sunday. So hopefully we're going to get a lot done today. Okay, so apart from these bugs that are listed here, I'm going to be optimistic and say we're going to get all those done. And then other things to do, dependency reduction in the compiler, like simplifying the dependencies that are in there. It's the out-of-order compilation model stuff. And the reason I want to do that is because eventually I want to do a giant rewrite of the way that works. We're not going to do it today. But the more I simplify what's there now, the easier it'll be to make it work. Okay. Dependency reduction. I have an idea for a new program to write that I'm going to write down on this piece of paper without saying what it is in case we don't do it. And then using run a name remapper, because you know, right now you can do that on a load directive or an import directive. I demoed that a long time ago, so you can change the names, but you want to be able to do that on using as well. And maybe you want to do some other things like accept some names, but that's the same as adding a name remapper. I don't know. Someone mentioned on Twitter if you could implement A*. Yeah, I'm not totally feeling that today, just because I think it's best to implement that when you have a program that wants to use it, because that keeps you the most reality-based, right? Like right now, if I just sit down and write A*, it's like, I'm not using it in anything, so it's a little empty. What would using the type even mean? It would mean like that. So if it's an enum type, then you're certainly using all the members of the enum. If it's a struct type, if that struct just declares constant members, then yeah, using it makes sense. So I'm just doing that. All right, so let's look at who calls this. Should be only called from, yeah, it's just called here. Bing. So I want to make another parameter. Maybe do using insertion. Okay. Right, we don't have a struct. We used to have, what's confusing me right now is we used to have a syntax tree node for using, but we don't have that anymore. Because the way the syntax was, it made more sense to do it a different way. So this declaration is now the thing that tells us what we're using, right? And it's the expression. Okay, so down here we have the type. All right. So I'm going to say, I'm going to make a new variable saying bool constants only, right? Restrict to constants only. Now the question is this correct? So do we ever using a struct, if we're at top level, does it make sense? No, we're just going to say it never makes sense. All right, so we're just going to pass that to the phase 3, because phase 3 is the guy who sees all the declarations. Now, because this is C++, we have to do this twice because it's stupid. So we have to do that there. And restrict to constants only. Declaration flags. So either it can be constant, or we'll add an extra thing and say maybe the size is 0. Like maybe there's a thing of type void or a struct that size 0, then we don't really care. So, well, no, actually no. So it's not constant. Report error. Using a struct that requires storage, but no storage was declared, and then we'll add additional information. Importer here is the site of the using, and then we'll also say info you can declare storage by saying, for example, using using value colon whatever. I'm going to be fancy and put the name of the struct. Instead of, this is a crazy error message, isn't it? Instead of using whatever. So I'm going to say name is struct type, right? And if you gave a struct I think that's this. Okay. Well, that didn't work. Why is it saying that's a using? Oh, no, because we're using it elsewhere. Okay, well, we're firing on a normal using that does... Oh, because I didn't... Right. I'm just always complaining if you import something that's not constant. I didn't... Yeah. So, because restrict to constants only is just always true if we're using a struct, and that's not right. So what is right? I guess importer needs to have a type inst, I think. If having a type inst means we said using x some type instead of using some type, because in the latter case some type, what's some type, not some time, some type will be in the expression slot. Let's try it now. Okay. Well, something's happening. Let's make our console wider. Using a struct that requires storage, but no storage was declared. Okay, so now all this spew is because when I say info, it's, yeah, set error location prefix to false. Because we don't, like this is being used to draw the location of the error every time, and we don't want to do that. Oh, maybe that was the wrong thing. No, error location prefix is the wrong thing. Well, we want that, but we also want, I don't know. Like I very rarely do these multi-line error messages. How do I make it not do that? How about, well, okay. I think if I use no label instead of info, that'll work. Okay, there we go. You can declare storage by saying using value IUnknown vtable instead of using IUnknown vtable. Let's put some new lines in there. I don't know what my policy is going to be for spacing and stuff, but all right. Using a struct acquires storage, but no storage was declared. Oh, I want to swap this around. I want this to be the site of the using, and this to be the thing requiring storage. Here is a declaration imported by the using that requires storage. So that's going to be this, and this is going to be importer. All right. Using struct acquires storage, but no storage was declared. So this makes a lot more sense. And here, line 2266 is a declaration imported by the using that requires storage. You can declare storage by saying, for example, this instead of that. I like this. I don't like the way this is displayed. We'll make it better later. Oh! Oh. Well, we'll think about some things. I thought I got a good idea for later in Superstream Sunday. Okay. It's going to be good. All right. I like the idea that we suggest a way to fix the problem because that's very helpful for beginners who have no idea what the hell's going on, right? Another thing we might do later when we're a little further along is put a link here of like, well, here's a link to a web page that discusses generally what's going on at length and why this is the way it is and so forth. So, all right. Let's make sure that Soakban and, oh, I didn't update, by the way, and some fixes to the LVM backend and so forth were, uh-oh, I'm triggering on all right. I think we actually found a bug. Well, let's see. Maybe it's not a bug in this case. Maybe we want to let you okay. Right. So in this case, build options, right, is a struct. Build options.lvm options is a struct. but it does have storage because it's in a parameter. So we need to be more sophisticated about when we're triggering this. It's not just that we're importing a struct, obviously. It's that the path to the path to the struct, like there's a chain of it's that the thing in the expression slot here, this thing is a value that has storage. So we want to restrict to constants only. Not in this case. Auto expers importer expression while expers substitution. We want to say if exper type, we want to know what the actual, no, okay, we want this thing. We want to say eval expression to literal or constant. If exper, okay, this is my new theory of when we should do this. Okay, so we still tripped on the actual bug. That's good. Wait, why was I running the... Wait, I just ran the debug okay, debug compiler. Oh boy, all right. Importer expression is not always... That's why I put that assert there, because I wasn't sure. Let's take a look at in what case. When do we not have an expression? It'll be something obvious that I just wasn't thinking of. And it probably doesn't matter. I just want to know. Okay, so importer, line number, importer, file. Oh, I hate the way it does that. Preload, line what? In the earlier versions of the UI, it would go down to the next line automatically, so you could keep typing. I know why they did it. They did it so you can type something and then hit right arrow to expand. But like, these keyboard commands are for dipshits. They didn't do them right. Anyway, it's so annoying. All right, so preload line 50. what? That's a totally normal. Oh, right, right. There's a type inst, but no expression. Okay. So we don't need that assert. It's fine. If we say using x some type that has a type inst but no expression, so it is guaranteed to have storage. We are looking for the case using some type that has an expression if all right, we eval it if it's a struct. Constantly in the ast, not if the type of it is a struct. All right, so we're back here. Let's just go for it and run the release build again. We're being optimistic. Hey, it compiled Sokoban. Sokoban runs. And let's go over here and run the tests. Boom, boom. Okay, well that's the old LLVM backend bug that I think if we update is fixed. So let's try that out. I think Josh fixed it last night. I saw a check-in for it. He was working on a Saturday. Hey, all right, great. That is excellent. Commit fix bug 72. Fix bug 72 by reporting an error. Maybe in the future we will make this a valid construct, but detecting the situation is the first step in doing so. Anyway, so here we go. Any questions about what happened there? While I warm up some tea. 5-minute tea break. Prefix questions with to so I see them clearly. All right, back in a second. We need, because I've been drinking iced tea so far, but I have a really good chocolate bar, and iced drinks and chocolate are not good together, so we need a hot drink. Back in a second. We are back on Superstream Sunday. I see questions in the chat. Using works on undeclared structs as long as they have const members. Yes. Yes, you want to be able to have a struct full of const members and not generate an error. Absolutely. What does solidification mean? That is what happens with integers. So if you have a thing, okay, let's say, for example, you just say x colon equals 5, right? Well, what's 5? Like, you need to know what the type of x is to compile that program. 5 seems like it should be an integer, right? It's not like you said 5.0. But how big of an integer? Is it signed? Is it unsigned? Or what? Well, by default in this case, since we didn't specify anything, it's a signed 64-bit integer, right? So we're solidifying this 5 into a more concrete type, right? But it's not all, like when you say 5 in a program, it's not always a signed 16-bit integer, because you could have like, you know, y is u16, and you might say y equals 5, right? So in that case, it gets implicitly casted to a u16. So it's really, it's just the process by which we decide what numbers really are in terms of their size, in terms of you know, are they floating point or not? So you could say, well, z is a float, and z equals 5, right? So in this case, we're allowed to implicitly cast this way to that way, right? But if we say w is an int and w equals 5.0, we're not allowed to do that, right? So this kind of, all these type checks have to work, even though we haven't completely decided the type of this number in any of these cases, right? You know, this could be float 32 or float 64. This could be any integer type, signed or unsigned of any size, and so forth, right? So it's just the process by which we decide what the number is. And probably that whole concept can be simplified a little bit, because when we started out, I wasn't sure how the language was going to work. And it seems to me now that there's a relatively simple, small number of cases that can actually happen. And this is probably most of them, right, in principle. So I don't know if it deserves a fancy falutin name of solidification anymore. Maybe there's just a small number of intermediate types that things can be. Can I explain the general parsing pipeline? Is this right? For each file, you make a job that converts the file into an array of tokens, then parses the tokens, then collect into the ast on the main thread. Almost, but not quite. So when you say convert the file into an array of tokens, you're presuming, or you're describing that first there's a whole array of tokens representing the whole file. And we never do that, because that's just slow. What we do is we just generate tokens as they're needed. Maybe it's not slow. Maybe it would be faster just to stay in the lexer and generate a ton of tokens instead of just calling into it. That would be interesting to think about. Maybe you're just more, yeah, anyway. The way it actually works is we load each file completely into memory, right? We load the text completely into memory, and then the parser asks the lexer every time it needs a token to give it the next token, and then the lexer, you know, parses as much of the remaining file as is needed to provide the next token. And it's a little more complicated than that, because sometimes you need to look ahead 1 or 2 tokens, but the tokens don't all exist at once. They're just read in. Although, actually, yeah, as you describe it, maybe it's better to do it the way you said and just make all the tokens. like, that's a little bit higher in latency. Because you have to make all the tokens before you can start parsing, and maybe that's not good. I don't know. Parsing is so fast right now that it doesn't matter anyway. Like, so if I compile Sokoban here, this line here is parsing. This is lexing plus parsing for the whole program. Okay, 25 milliseconds out of a 0.75 second time, right? So that's 0.025 seconds, right? It's like 1/30th of the compile time is lexing and parsing. Now that includes all this stupid time we're spending in the linker. So if we can get rid of the linker, then we're at more like 1/15th of compile time is lexing and parsing, and that starts to be maybe something that you think about. But right now it's just so fast that it's really if I start thinking about what to optimize, it's not that. You mentioned including links with error messages to show full explanations. What do you think? Would this be a link to an official site? It would be a link to an official site. I don't think there would be comments on the page, Stack Overflow style. Maybe if we thought that would be useful. It's just, most sites like that are just garbage, right? Like Stack Overflow is probably one of the better ones, but even then, many of the people who post, like if I search for like how do I do a certain thing, and I vaguely know how to do it, but I'm just looking up the specifics, and I look on Stack Overflow, usually the answers are not written by people who really know what they're talking about. So I'm wary of that kind of thing. And Stack Overflow is the best one, right? If you look on like the Microsoft help pages or something, just like everything on there that's user comments is just misleading garbage for the most part. So I'm not a big fan of that kind of system. That said, maybe there's a way we could do it that would work out well. I don't know. But the initial idea is just that they would be statically pre-authored pages that go into a more in-depth discussion, because like if you're trying to compile a program and you get an error message and you don't understand it, why should you have to go to some second-hand or third-hand source of people on the internet who maybe don't understand it trying to explain it to you? It's better if the people who made the software just put some effort in and explain to you what's going on, right? And you know that they know what they're talking about because they wrote the software. So that's the problem with the internet, right? One of the utopian visions of the internet is that everybody can contribute and help out, and that's great, but the problem is, you know, the Sturgeon's Law thing where, you know, most people, 80% of people don't know what they're talking about when they talk about a certain subject, or more, 90%, 95%. So that's the problem with that approach. Have I ever thought about representations of code that would communicate the high-level algorithm that you had in mind when you wrote it and have it be generated from the code and not a separate artifact? I mean, there's a whole field of programming language design that is that. And I haven't looked at that field lately. I don't know what they're up to lately. I've thought about it for sure, but not in a long time. This language is not that, right? This is more of a be very explicit about what the computer should do type of programming language, which is not to say that that other kind isn't a potentially good field for study. It's just not what I'm doing this year. So any word on SOA? Nope. It's going to come back still, but you know, it needs more features to come back, and as you can see, I haven't been adding new features. I've been working on robustness. Have I heard of the Crystal programming language? If so, can I complain about it, please? I have heard of it. Somebody told me to look at it, and I looked at it, just the front page, and I looked at the description, and I was like, it's not really what I'm interested in. But I don't know anything about the specifics of the language. I mean, there's so many programming languages out there. there's no way for me to know very much about most of them, actually, right? Like to actually know a language well enough to give nuanced comments on it, I think you have to have been using it for at least 3 years or 4 years seriously. And so I'm only 45 years old, so at most, if I started programming when I was a baby, I could have nuanced views on 10 languages. But of course, it's not even that. I have basically nuanced views on 2 languages or less. So there you go. ETA on release. Well, we did a thing a little bit ago where I said I want to go into closed release in about 3 months, less than that now. But we'll see. That we might slip that schedule. And I don't know what the closed release schedule means for the open release. Using it for a school project in the summer, it's probably too soon, if I'm being honest. We probably won't be out by then, as a public release. Any ideas about cross-platform programming and special support for it? I don't see any need for special support for cross-platform programming apart from the systems that we already have. Like, in a sense, C++ is already fine for that. The problem in C++ when it comes to cross-platform programming is just wrangling all the libraries and all the stupid things, the build system things that are different on different platforms. And those we have fixed in this language. So we've really already hit the biggest problem in cross-platform programming. So maybe you have some specific issue in mind, though, and if so, let me know more specifically what you mean. Because cross-platform programming is just a very general idea. I mean, if anything, C++ is a much better language for cross-platform programming than some of these other things like Java or whatever they claim to be write once, run anywhere. Because in C++ you can drill down and do the specific things that you need to go fast or to do specific functionality on every platform. And that's one reason why games still use C++ primarily, right? Because when we're doing a renderer on the PlayStation, we can write our PlayStation specific code and link it in, and it only runs there, right? Is everything a 64-bit integer by default, even on 32-bit platforms? Yes, we're ignoring 32-bit platforms. You know, we might go back later and do some 32-bit platform support for embedded systems, but we'll do that later. For now, we assume the target platform is 64-bit. And that's a safe assumption, because even for games, even for 2D platformer games, at this point, a 32-bit address space is probably too small. It's just too small. You can't fit enough data in it. So very few forward-thinking games are 32-bit these days. I think Valve still ships 32-bit games, but maybe that's not even true anymore. Like, they do it just to get maximum compatibility across older operating systems, but even they are going to be feeling the pain of that soon. Rust and Swift has a gap with the Rust and Swift have a gap with the expressibility of LLVM-IR to the point that Swift created SIL, which I assume stands for Swift Intermediate Language, but I don't know. Do we have a similar issue? No, we're not using LLVM-IR as our own intermediate language. No, because we don't want to take that much of a dependency on LLVM. So we are able to compile a complete program without touching LLVM at all. You only get LLVM if you ask for it. So yeah, we have our own intermediate program representation, and it's exactly what we want it to be at all times, right? It's not predicated on LLVM or any other external system. So, you know, when we engage with the LLVM API, we're converting our intermediate representation to theirs by using their API. Cross-compilation. Yeah, I would like to, in principle, make everything work everywhere. The only problem with cross-compilation is you kind of need the linker sometimes. Like I don't know if there's a way to generate a Linux executable without linking against Linux libraries, for example, right? In Windows, I can create an executable that doesn't do that. And maybe you can do that in Linux too. I just don't know how to do it yet. And then, you know, I mean, we'll see. I want to be as, like ideally, you should just be able to kick off a build on whatever operating system you're on and build executables for all other operating systems from there, right? The only thing standing in the way of that is this culture of weird tool chain dependencies that we've gotten ourselves into as programmers over the past decades, and I'm trying to dig us out of that. The question is just whether we can do that all ourselves. So we'll see. Someone said goes against fail fast principle. I don't know what that's in reply to. If you're 45, you should update your Wikipedia page. I don't write my Wikipedia page, man. I'm actually 46. Do I think 64-bit will be the last resizing of address space? No. I mean, as long as humankind doesn't blow itself up, we'll need a bigger address space eventually, but not for a long time. 64 bits is really pretty large. 64-bit is large, but you got to be forward-thinking, right? Like, we'll need 128-bit eventually, for sure. I mean, it's hard to imagine. It's hard to imagine why we will need that, because 64 bits is so big. Like, if you just think, hey, that's how much memory I have, it's just an immense amount, right? But don't underestimate our need to use resources in some way or another, right? So, like, we won't need 128-bit for a long time, but do you really want to say 200 years from now we won't need 128 bits? Like, 200 years ago, it was 1818, right? And people were riding buggies around. And actually, in the United States, like, we were pre-Civil War, right? We had slavery and cotton plantations and stuff. So, and like the Wild West. So the world is so different from that. You know, now you can fly to China. Now you can book the flight 1 hour in advance. You get to China, you get out your phone, and you can figure out where you're going, right? Without having pre-planned the trip. So the world is very different today, and you just have to assume the world will be equivalently different or more different than that 200 years from now. So yeah, there's no way that 64 bits is the final resizing. I just can't tell you why. Why do I dislike Rust again? Just go see some of my rants. I don't want to repeat myself too much. Can I move the face cam? Can't see the close button. You're trolling me so hard right now. You can, but it means statically linking the C library and getting all the disadvantages of static linking, which also means I need to run a linker that knows how to link elf or whatever the format is on Linux. So it's, I mean, maybe we can just ship LLD and do that, but man, I don't know. Why game development? What is the real motivation behind selecting this domain? I just really like games. I can't tell you what you should care about. If you don't feel driven to do games, then don't. I certainly could make 10 times more money or more working in another field, right? So it's not financial motivation that brings me to game development. It's because I like games and I think they're interesting. Do you still think that World of Warcraft causes societal problems? Yes, but not by creating a false image of the meaning of life. I think it's because they're compulsion loops. But the thing is that iPhone games are so much worse than World of Warcraft that I wouldn't give the same speech today, right? World of Warcraft was like the leading edge of the creeping cloud of doom that has now enveloped everybody's brains, right? I mean, World of Warcraft is not bad compared to Facebook, for example. Facebook is horribly abusive and manipulative. So, yeah, it's still a problem, but we have way bigger problems now because nobody took the problem seriously back at the time. Are there any security implications that you can foresee to keep in mind when using temporary storage? I mean, it's a storage buffer, right? I mean, anything in there could easily be read by any code that you call, but you know, that's true of any regular memory buffer. It's maybe a little bit easier because everyone knows where it is, but like anyone could scan your malloc heap if they wanted to. So it's just regular code. 256-bit address space is more bits than particles in the observable universe. Yeah, I mean, but 256-bit is bigger than 64-bit. So that's all. Don't underestimate JavaScript. Yeah, it's true. Am I going to implement any retpooling type mitigations? I don't know. Not anytime soon. I want to just see everyone else get their act together about that and what people's conclusions are, and then I'll do something maybe. Is it feasible to write a complex physics engine from scratch versus just using something like Havoc? Yeah, I mean, back in the early 2000s when computers were a lot slower than they are today, like around 2004, I was working with a guy named Ottman. He's now like chief something at Oculus. I don't remember what his official title is. But he just wrote a physics engine from scratch, 3D rigid body physics, in less than a year. He was doing awesome. He just cranked it out. Those were good times. And that was back when programming was harder than it is today, because compilers are faster and computers are faster. So you could totally do it today, yeah. So the compiler generates from syntax tree, or you go to an IR equivalent. We go from a syntax tree with full type annotations to an intermediate representation that's bytecode that we can run or convert to an executable program. Yeah. Where do we do loop unrolling, escape analysis, etc.? We don't do any of that stuff yet. LLVM hopefully does that for us in an optimized executable. At some point soon, we're going to start doing some data flow analysis, but we don't do any yet right now. It's not necessary. To generate a working executable, you don't need any of that stuff, right? That's just optimization. And of course, just optimization is a sarcastic phrase because you can put an infinite amount of work into optimization. So, you know, yeah. Will the game engine contain a GUI library for games, or will you use one of the open source libraries for that? No, we're going to have our own GUI library. Yeah. And we may talk about why today, depending. I don't know. We'll see. Thoughts about immutability? I don't know. I mean, immutability might be fine. So far, we experimented with immutable procedure parameters so far, and it was just a pain in the ass. So, with no real upside that I could see. That said, there might be some value in language constructs, such as, for example, hey, here's a local variable. It's mutable for a bit, but I'm going to declare that after this point of the scope, it's now immutable for the rest of the scope, like I'm going to lock it down. I felt like sometimes I might like to have that to mitigate bugs, but that's not the same as the general immutability that these languages tend to champion. Did I write a compiler for PS4 yet? We don't target PS4 yet specifically, but I don't think in principle it'll be that hard. We plan to do it. Have we hit any bugs caused by the LLVM optimizer yet? You have one that optimizing things out at 02 but not 00. Fun. Yeah, I haven't seen that yet. But I won't be surprised if that happens. Let's put it that way. Bitfields, ever use them? No, not really. Have I gotten to use my refresh telemetry license yet? No, we might do that a little bit today, depending. Let me write that down on the paper. Telemetry. It might be fun. Maybe we don't even optimize anything. We just look at where the time is going these days. Sorry for the off-topic question, but I can't seem to get skinning right. If I 100% know my animation frame joints world space positions are correct, what transforms would I need to do to send to the shader for transforming the vertices? So whenever I implemented skinning, I always would do it in software first to make sure it works, right? So I would generate all my world space positions in software, just like you said you're effectively doing. Or you said you know the joint positions are correct. So the next step would be to have a software skinning path where you figure out all the vertex positions correctly in software, and then you just use like an immediate mode style API to just send all those triangles to the GPU, right? So I have a thing where I say immediate begin, here's a bunch of triangles, immediate end. And so as long as you've got rendering working for static meshes, right, you should then be able to render that. And then you have a thing where you can animate your guy and it works. And it's maybe just slower than it would be if you did skinning on the GPU, right? Then you can move forward and do the skinning on the GPU, but at that point you'll know exactly what needs to happen because you have it on software, right? And you can just push it over there. So I recommend that. It just makes things very clear. Otherwise, yeah, if you just try to write skinning on the GPU, there's so much of a barrier there that the invisibility or the lack of good communication with the GPU really makes it hard to debug when something's wrong. And if there's multiple things wrong, which there probably are, it's really hard, right? So once you start, so I recommend first put it in software. Second, and get it working so it's visually correct. Then when you want to move the things over to the GPU, the next step can be just draw all your bone roots in the shader somehow. I mean, by the time, I don't know. I mean, that starts to be annoying again. I don't know. You just kind of have to make the leap at some point. I borrowed a technique I saw on the stream where you output a graph viz PNZ after a crash. It was really useful in tracking a memory leak. Thanks. Yeah, I didn't think of that. Some people recommended it to me. So it's not my technique, but it was helpful for sure. Witness release for PS4 and Xbox One. Would you say both port were easier to implement than it would have been for Linux? Yes. Yes. Both were easier than it would have been for Linux. All right, that's a lot of questions. Let's do this next bug. Bug 78. Which one was that? I don't know. It might have been one that I'm not going to do. Oh, it doesn't have repo. Oh, it's this namespace thing. I skipped this before, so let's look at this. So Ignacio did this thing. He made these two files, A and B, and they're really simple. And, you know, when I import things, we're supposed to be doing deduplication of the library. But for some reason, and so he's compiling this file, right? which imports B, which imports A. And so this should be deduplicated in principle, but it's not. And I'm not sure exactly why. Maybe I'm just not going to fix it, because when we do the library thing, this might all change a little bit. But let's at least look at what's happening, right? Anyway, so what happens is when we run on A, we get pi as redeclared, right? Which, you know, in theory we shouldn't, because this import shouldn't do anything, because we already had A. But let's find out. It might be something with relative versus absolute paths. It might be that this is, I think what's happening is that this is not a library. This is not considered a library, probably because it's the main program. I don't know. I don't know, man. So there's something having to do with directive load that does this. Not message for load directive, but someone probably calls that. Modify directives, run directives. Where do I get my load directives? Let's look in parser what we do. What we do when we get a directive load. All right, we fill it out. We queue it for resolve. So that means in typer, accept top level expression. Right, I remember this. So if it's a load, we say add directive load. Can't type. Load. Okay. So I'm just going to look for that. Well, is this where the deduplication happens? Yeah, this is where we check for it. So here we go. Oh wait, I gotta set it up to run the right program and all that. So bug 78, let's rebuild. Am I planning to expose memory visibility primitives, write barrier volatile addresses, etc.? Yeah, we need that stuff, especially on consoles, but also on PC. You need that stuff. I just don't know what the interface is to it yet, but yeah, that's going to be in there. Does myint : int make a distinct type or a type alias? It's an alias, so those two things would be exactly the same. Witness released, oh, we already answered that. I often break out of functions early because I find it more readable versus having an if block running to the end of the function. So do I. I break out early all the time. I would often like to do this in regular code, return to upper scope. Do we have anything to enable this? Not yet, but it might make sense to add. I definitely, you know, if you mean break out of the middle of this block and go to the next block, yeah, I could totally see that being a thing. There was a robustness note there. It's true. Since I'm debugging this, let's look. Okay. It's about paths, so it might be relevant. This is not actually right. We may still load something twice if the path and file name are ostensibly different, but concatenate and canonicalize to the same thing. So we also want to deduplicate on the back end once we know the actual file name, but we want also to handle the re-import thing below. It's a little complicated side. And all this will change when we change the way libraries work anyway. So yeah, I might punt on this if, but let's see. So now we're probably loading A, right? Or we're probably loading preload, right? How do I, wait. No path, no name, no string. For the preload, do we send through something with no name? Let's see. Okay. Name. Preload. All right. That's fine. Preload defines some things that the compiler works with later. Let's just put the breakpoint here. Okay, there's no expression this time. We have a name, we're loading A. Okay. Adding it to load directives all. Load flags is 0. It might be that import looks for load flags that are not 0, right? So now we're loading B, right? Yeah, it's going to be a load flags issue, right? Okay, so next time, now we're loading A, I bet, right? Yep, name is A. And the load flags are going to be different, right? So my load flags are 1, which means I'm a library, and, well, let's look at what they are. Let's not presume. Load flag import, yeah, which I guess means library. Okay, so load flags on these other guys, so this is going to be B, which has load flag 0. All right. Wait. Oh no, this is B, yeah. So A had load flag 0, B had load flags 1. All right, my solution, the reason Ignacio wanted to do this was because, like, hey, if I'm working on a library, but it's not officially a library yet, I may want to do it as a program, and so forth. And my proposed workaround is going to be the following. Well, let's make sure this works before I write a long comment. So here I'm just importing B, so I'm like, hey, that's a library. B is importing C, and C is importing B, right? So now, hey, it works. Okay. The problem with the earlier example is that when deduplicating load imports, we ignore things loaded with load because those are considered as part of the application, and we want to avoid may have name, save names, etc. When you start the compiler on an initial file that is considered load, not an import, that is did not deduplicate with the later import A. The workaround for this for now, if you want to offer is just to have your initial file import something like as below, then it will deduplicate. Maybe this is slightly annoying, but we are going to change the way libraries work later anyway, and that may invalidate all of this, so there's no use getting too worried about it right now, at least I don't think so. 2018, there we go. Change bug 78 so that it works, add an explanation. And then on my other monitor here for a second, I'm going to email Ignacio and say, bug 78, import deduplication. I fixed this by changing the example. See comment at the top of bug 78. All right, great. Okay, now I have to think about these. I'm more worried about this one. I feel like this might have been due to a different bug that has since been fixed. But the way to know that is to try it out. Yeah. Any plans for coroutines? No. No. All right. I'm much more concerned with solving difficult performance-oriented parallelism problems. And coroutines don't help with that. Coroutines are just a different kind of parallelism that I'm not that worried about, honestly, because it's not that hard. Okay. Yeah. I'm going to have a little chocolate because I'm feeling good. Didn't get enough sleep last night because I was up playing PUBG till 2 a.m. But it was a little irresponsible to do that before Superstream Sunday. But sometimes you got to PUBG all night, you know? So I'm a little tired, but the chocolate's going to keep me awake. This is a very, very good black salt caramel chocolate bar, which you can probably get at Whole Foods. It's really good. Okay. Evaluates type of at compile time results in an error. Well, that is certainly not true. Let me first make a test. Let's kill this A, B, and C, because we don't want these buffers hanging around. Okay. I'm just going to paste. What is happening? Someone just stole my focus in a totally different window. I'm just going to paste this comment here. And now we're going to make a very simple version of that. We're going to say Foozle is a struct. A is a float, B is a int, C is a vector 3, and so we're going to import math so that we have vector 3. Not vector 3, import math. Math, mofo. All right, main says Foozle is a pointer to a Foozle. Assert size of Foozle is equal to, is it going to be 28? I don't know. Let's see. Yep, size of Foozle is 28. Great. Assert size of type of Foozle attempt to use variable from an outer stack frame. Closures are not supported. Right. So the thing is, this assert makes lambda effectively and runs it. And hey, the lambda is not allowed to capture things from the outer frame. But to know the type of something, you don't need to capture it. You know what I'm saying? So the question is there a good non-total hack workaround? I wonder if this works in global scope. It does. So type of could put a tag on its little expression there. The thing is, we would have to propagate that tag across everything. And what if it's like a run directive or something? So let's just take a look. I think I know where this happens, but attempt to use a variable. So this is when we're resolving an identifier. Yeah. So if the identifier is flagged, do we have? So basically we say, hey, if the identifier is inside a lambda and we're not in the resolving to a constant, then blah, blah, blah. Okay, it's a very specialized error message that's supposed to catch cases when people are doing something wrong. Okay, first of all, let's just make sure that if we disable this message, that the code actually works, right? So if we go back to this, yeah. So it works as long as we don't stop it from working with our helpful error message. The problem is that that helpful error message is probably required to make procedures not crash. I don't know. What happens if I just make a lambda that tries to use it? So bad lambda is something that says print foozle is. Now this is bad because that's not in our stack. It's in an enclosing scope, and it's no good. So yeah, the compiler just asserts because it expects us to have caught that. So we need to catch that. So I'm going to do a really ugly hack, I guess. We have flags on identifiers. And I'm going to say ident is inside type of, right? Later, like if there's other cases in which we need to do a similar thing, then this name may change to be more general, but for now we're just saying, no, it's inside a type of, whatever, man. Now, we do this thing that might change later when we redesign the compiler, but we like flatten out things here. What is it called? Size or type of. Okay. Before we flatten the type of expression, we're going to say, so I'm going to want that there. So when we call C, we call flatten recursively on this. And flatten there's a thing called current flattened result. Okay, so let's do this kind of comment because we're getting serious here. We need to make the following case work, or we need to allow the following case to work. Assert makes a lambda that needs to reference Foozle, but because Foozle is inside type of this doesn't count as a reference to an unclosed variable. So, to an outer scope. So right now we mark it any idents in the expression. The way we do this is kind of yucky, but I am not sure. It would be cleaner. I'm not sure the whole system would be cleaner if we did some kind of tree navigation thing instead of flattening, but we do want to consider that in the future anyway. Okay. So let's do all this inside so that we know what this comment refers to. We're going to do all this inside a block. All right. So it's called current flattened result. If source type of expression, let's just put that out here. After count for before count xvar is current flattened result sub I. If xvar type is asked ident auto, ident is static cast asked ident. So this array that we're zooming over basically contains a pointer to every syntax tree node that's in that expression, because we might not just be saying type of an identifier. This could be a really big expression of like subscripting and dereferencing structs and all sorts of things. For any identifier in there, yeah. Yeah. All right. Maybe that'll first figure out what mistakes I made. 9430. Is that an arrow? Yeah. I keep hitting. What is going on? Oh, it's just not popping me to the output window. All right. So, hey, that's great. Now let's go and make sure this gets caught still. Oh no, wait. Oh, right. Okay, we don't know because I accidentally left our thing. I left this commented out. That needs to be turned on for us to know if it worked. Didn't work. Didn't work. Oh, because I'm not checking the frickin' thing that I added, right? Like, it doesn't help to set this if nobody cares. If not ident flags and that, boom. All right. Whoops, mistype. Hey, all right. So now, let's make sure we catch this and don't assert. Hey, okay, great. Now, let's make sure that the tests and Sokoban still compile. Sokoban. Tests. Hey. Fix Ignacio reported outer stack frame bug. Error report bug. Okay, let me send him an email, and then there's a philosophical discussion to have about what I just did that I think is important. Because that was not an ideal solution, and we'll talk about why. Well, it may be ideal. I don't know how to explain, but yeah. Okay. Right into the team, I'm saying, hey, outer stack frame bug reported by Ignacio. This is now fixed. I will point out, though, actually, I'll just send this to Ignacio instead of the team because nobody else needs to know. There is a subtle bug in the example you sent. Size of type of DXGI device will be 8, but that is because it is a pointer, not because of the size of the DXGI device. Okay, that's great. Let's get rid of this out of our notes. Okay, let's talk about fixing bugs and stuff. So the reason why I said that was not an ideal fix is it added a complication, right? There's like a new identifier flag, and we had to set that flag, and that flag had to be set at the cost of some CPU time. Now, fortunately, it's CPU time that doesn't affect very much because it only kicks in when you're inside a type of, which is a very small percentage of your code, right? But like, we added code, we added a flag, and it's just, you know, it would be nice if we could fix it without that. But I don't, the way that the code is set up, I think that is maybe the best solution. It's at least the best I can think of right now. So all this is just to say, even though I don't know a better answer, it's a good habit for me to be not completely happy with the solution I just did. because we would like something cleaner and we would like something nicer. And too much programming, like the kind of programming that generates code that falls down after a long time, is the kind of programming that just adds tons of stuff like this willy-nilly and doesn't ever care and doesn't ever try to compact them or whatever. So at some point in the future, like I said here, you know, we do want to consider this alternate approach that instead of flattening, you know, maybe we do a tree recursion kind of thing or something. I'm not convinced that that's better. There's a lot of advantages to flattening, but it might be better. And if it's better, then the function of this is to show us that there's a piece of functionality that needs to happen. We need to distinguish between identifiers in one context and another, and we would like to do that discernment more simply than we are. So that's all I want to say, is just that was a little bit like, if you know what I'm saying. All right. If I send you my puzzle game, do you have time to try it out? Probably not. I just get a lot of people sending me puzzle games. Why do you even need to do type of var for size of? So because, okay. I'm trying to think about, trying to remember all the intricacies of this so I can explain it. Okay, in C, let's talk about C for a second. You can have a vector 3, well, we're talking about C. Struct vector 3, x, y, z, I keep switching languages. Float, x, y, z, semicolon, right? That's C. This is new C. In old C, you had to say type def struct blah, blah, blah. But this is new C, whatever. OK. Then you can say vector 3v. And you can say auto, well, whatever, auto int size ts is size of v, right? Or you can say size ts is size of vector 3, right? And in C, there's a subtle thing that happens, right? These are like two different things. When you say size of v, it's like, okay, what's the type of v? And we'll give you that type. And if you say size of a type, it just gives you the size of that type. In C, these are two different things, right? The variable, like a first class value is what v is, and this is not a thing. Like you can't have a variable in C with the value vector 3, right? It's a different thing. Okay, so in this language you can do that. So let's first put down the equivalent code. So I can say vector 3 is a struct, x, y, z are floats, right? And then v is vector 3, and then s is size of, well, type of v, and s is size of vector 3. Okay, so the question is like, why do you need this type of? Why don't you just have size of work like it does in C? And the reason is the following. It's for clarity, okay? What if I say the following thing? I'm going to have some t is a type, right? And I'm going to say t is vector 3. That's valid. We can do that, right? In fact, well, this example is a little too simple to be serious, but we'll start here, right? So the problem is you can't actually say size of t in this context. Let's go to an example that's, all right, we're going to say some f is a function. It takes x of some type t, right? So it's a polymorphic function. We don't know what t is, right? We're going to say S is size of t. I'm not remembering my explanation very well. Anyway, let's do the following. We're going to call f on a type. We're going to say we're going to say like we're going to say the value has to be known at compile time, and we're going to say f of vector 3. We can do that, right? We can call a procedure with a type argument. That's totally valid in this language. It's not valid at all in C or C++. I mean, there's template-y hacks in C++ that kind of let you do it in some contexts, but you can't do it generally, whereas this works, right? So here, if I say S is, what's going on? My keyboard input is, happening, colon equals size of x. We could do that. We could say, we'll say S1 is size of x. S2 is size of t, right? S3, size of type of x. So S2 and S3 are always going to be the same, so let's put them next to each other, right? Because t is the type of x. But this is a valid thing that you might want to say, because x is a type, right? So if we say f of vector 3, x is going to be vector 3, t is going to be type, so it's going to be like size 4 or 8 or whatever size type is, I forget. So this will be 12, because vector 3 is 12. This will be 4 or 8. And these are two different things that you might want to say. They're both valid. So if you make size of a variable always mean the size of the type of the variable, then you can't actually say this ever. There's no way to express it. And because people are coming from a C background, let's say you made a way to express this, but you said like size of value or something, right? People coming from a C background are going to accidentally say size of on this when they mean that. Now, maybe I'm just being too paranoid and it's fine, because the percentage of time you would make that mistake is small. I don't know. I don't know if anyone's understanding what I'm saying here, right? I do think having to say size of type of this is annoying, because I come from a C, C++ tradition as well, where you can just say size of the thing. But I'm erring on the side of being overly cautious in the near term until we get everything figured out. You know, at some point we're going to do a syntax change. We're going to list all our gripes about what's inconvenient about the current syntax, and this will be one of them. And we'll say, okay, does it make sense to let you just say size of the thing? And I don't exactly know. That's all. Should it be size of and type of with a hash like assert to denote compile time, or aren't they compile time? They are compile time. I don't know. We're a little bit inconsistent on that. It's just, it feels like if we make everything use a hash mark, then it's really tedious and annoying. But maybe it's fine. Maybe that's the right answer. Maybe consistency is the right answer. It's true. Swift also has that distinction. Okay. I missed the beginning, so you can't size a var. Yeah, hopefully, I mean, that's a while back. Yeah, the question was like, why can't you say size of var? And hopefully, my explanation made sense. It's basically this. It's basically that S1 and S2 are different things, sometimes validly. And it might be that this is like a corner case that we don't care that much about, but I'm being overly cautious. It may end up that you just say size of var and it's fine. I don't know. What do I think about the compiler potentially changing source files? When you add captures, you could add something to signal the compiler to fill in the variable names. I don't like the idea of modifying the user's source files ever. Like, I think if you want your IDE or editor or whatever to magically do that and you're okay with that and you sign up for that as an individual user, that's great. But like, making the tradition be that the compiler writes back to your source files is bad. I think it should be a one-way thing. It's just clean that way. So you can use X in a var declarator like myvarX. Yes, absolutely. In this routine, because this X is known at compile time, you would be able to say value is an X and print value is whatever, and you would get a vector 3 of all zeros in that case. I mean, let's just do this, right? Let's go back to our test program that we just wrote for this foozle thing, comment out all the foozle stuff, and we'll just do this, right? So we have an F. Hopefully I didn't make a dumb typo. Let's go back to the other folder. All right. So there we go. Value is a vector 3, blah, blah, blah. So this works. And when you're doing generic programming, you may well want to do this. I don't know. Let's print the sizes. So yes, as you see, these are different. So that's the point. The point is that sometimes the size of the variable and the size of the variable's type are different answers. Oh yeah, the ambiguity in C with size of arrays versus size of pointers. That's true. That's true. It confuses people sometimes. I was confused when I was learning C for the first several years about the way that arrays implicitly cast to pointers and how that's different and what the memory representation is and all. It is just, you know, it's obvious now, but for some reason, like especially in K and R C, where like it wasn't as strongly typed, it was rough. Can you get the size of T? You said you can't use size of. So, okay, if the thing about this case is all this is known at compile time, right? If it's a runtime case, so you could do this thing. You could say T is a type, right? And let's just make it more indirect by making a function. We're going to say T is g of like 1. And I'm going to define g as returning a type, and we'll say if x is equal to whatever, case 0 return int, case 1 return vector 3, case 2, well, we'll make that a matrix. Matrix 4, 2 is vector 2. This is really arbitrary. And any other case, return void. Right? This is a totally valid program. And note that this doesn't even use dollar signs, right? So these are all runtime values that we don't know, right? So actually, let's do this. Let's say for 0 to 3, print g of whatever is whatever, and it and g of it, right? So, whoops, I forgot the variable. You got to say what you're switching over. And this is capital T. Right? All right, so there we go. G of 0 is S64, G of 1 is matrix 4, G of 2 is vector 2, G of 2 is void. So this is a totally valid program. We're talking about types at runtime, right? So that's one of the differences between this language and like C++. It's more like what a functional language does. Functional languages have a long tradition of talking about types at runtime, and we're just giving you the ability to do that in a compiled language, a statically compiled C-style language. Okay, so I could say T is a type. Let's move this down here now that we've done all this stuff. T is a type, and T is G of 1, and print T is whatever. So first we'll do that. And then I'll say print size of T is whatever, and this just won't work. It doesn't make sense, right? Wait, did I get a redeclaration? Yeah, no, it's here. Okay. So it's saying, hey, we're trying to evaluate a constant type, and it's a non-constant declaration, right? It's like T is some type. We don't know what the size of it is at compile time because you can assign it to anything, right? So this is not a thing you can do. You can do this. This is another reason to keep size of and type of separate. You can do this, but this is just going to give you the size of type, which is 8, right? It's not going to give you the size of a matrix 4, which is much bigger. And so if size of gave you size of type of automatically, you might think you were getting the size of the value of T, especially if you're a beginner programmer, but you'd be getting the size of type, and that might be bad. Does that all make sense? What is the type value converted to give it a legal value? Well, every type just has a serial number. And if you're compiled for embedded systems mode that doesn't have the type info, then you just get that serial number. Otherwise, if you do have it, then you get the pointer to the type info. There's a whole data segment in your program with the type information if you choose to have that. And then they're just the value of the pointer to that type information, which is why they're 8 bytes. What do I think of the ABAP language? Never heard of it. No idea. All right. I'm starting to feel like a break, but because it's Superstream Sunday, we're not going to take a break yet. Because, you know, no, that's not the right one. I should name these buffers. Okay, I'm going to get some more hot tea, and maybe we'll do some more questions. Maybe I'll attack this bug again. I'll probably take a break sometime between half an hour, like a long break in an hour or less. So this is going to be our last little push. Extreme programming, yeah. Superstream Sunday is a recurring thing. We did a Superstream Sunday 1 year ago. just one way to make that less ambiguous for people coming over from C or whatever might be just to rename size of to size of type. Yeah, someone suggested that, and it's something I've been thinking about. So you could say size of type, and that makes it clear that it only takes a type argument. Am I coming to reboot develop again? I don't know. I kind of would like to, because Croatia was fun. It's just really far. So I have to decide if I'm willing to do that travel. But I maybe have reasons to go to Europe, so we'll see. Did I reach any conclusions about the library module import system? No, not yet. I mean, the conclusions are still what I said during that stream. All right, tea's ready almost. Okay, I'm going to put that actually, there's an ideas file, rename size of to size of type in order to reduce ambiguity, especially for people coming from C. Okay. Any other questions we should do before we move on and fix another bug? This language is not out anywhere yet. We're going to go into limited release, hopefully in a few months. And then we'll be expanding the scope of that release as we are ready. And I don't know what the time frame is on that. Will it be possible to load libraries at runtime? Similar to how Java can load external jars. I mean, you can load dynamic link libraries if you want. That's just a thing that programs can do, and so that's fine. If you wanted to invoke the compiler at runtime, that'll just be the compiler is available as a library, and you can compile things to DLLs and run them. I don't recommend that for most use cases, but you could certainly do that. Swift has a ton of bike shedding on size of type. They opted for a generic memory layout T so that the other values of the layout could be together. I'm not sure what that means, but the other values of the layout could be together. I'm not sure. I guess I would need to know more about how Swift works in order to understand what the layout is and what memory layout returns. Oh, Handmade Heroes on. All right. Does the language have goto? It doesn't yet, just because I haven't needed it and I'm implementing things in priority order. But we probably need to have goto, because you just need it. So we're probably going to implement that in branch labels and stuff. And so, you know, someone earlier was suggesting being able to break out of a block. And, you know, that's like a specialized form of goto, just like loop break and continue are forms of goto. And actually, just like return is a form of goto. So, we'll have it. It just hasn't, I haven't needed to use it one time yet. So that's why it's not implemented. Stride in size. Yeah, okay. When do you really need goto in real life code? Once in a while, once in a very rare while, it is the best way to do something. I don't remember when, but I've definitely had a couple of cases in which it was the best way to do something. But that's across decades, so but again, that's stylistic. Like, some people might like to use goto more than I do, and they might have developed a style in which it's effective. I don't know. Memory layout of a type is size, stride, alignment. Okay, I mean, alignment is weird because you want people to be able to change alignment, so it's more like the default alignment of the type, I guess. Is the data segment type information duplicated for each object file generated since the MS linker is used? Or will the future linker compress that into only one table? Okay, we don't generate multiple object files. That is not our compilation model. Our compilation model is we compile the whole program at once into one executable. Later, when we do incremental compilation, we won't write object files either. We'll write intermediate files that are closer to source, because a lot of the features that we implement, essentially require the ability to recompile procedures, and we'll see more of that actually in future features. But anyway, so no, we don't do multiple object files. There's an open question of what happens if you link a library that's an object file, what happens, but we're just not going to try to solve that anytime soon. Can you return a fixed size array? Yeah, so I could do the following thing, at least I hope, maybe there's a compiler bug. A is h of 300, right? And h is going to be a procedure that takes, we know the length at compile time, for example, right? And we're going to return an array of length of U16s. I'm going to say result is length U16 for result right? Let's see if that compiles. I don't know. Non-constant expression. Uh-oh. Uh-oh. I may have a new compiler bug to work on, because that sure should be a constant expression. All right, let's comment this out. This was more sophisticated than we need, so we'll comment this out and we'll do the other thing, and then we'll come back to this. So let's say we're passing the value we want to initialize and returning 100 U16s. For 0 to 99, result sub it equals value, right? We'll make that a U16. So yeah. I don't think print prints the values of a long array like that. Oh, wait, we've got our old thing here. We can't do this. All right. Yeah, so we returned 100 U16s, right? And they're all initialized to 300. So this works. Now, I guess we have a new thing for me to do, because this didn't work, and this is supposed to work. So I need to figure out why that didn't work. guess that's how you know it's SuperStream Sunday, finding new bugs. All right, so when I try to compile now, non-constant expression in array declaration. I'm hoping this is just a stupid bug that's old. In array declaration. Let's just see. I think I'm just using an old routine. Oh wait, I gotta run the right program. It's test. Not A anymore. Okay, so what's expr right here? Expr is an ident. It has no substitution. The identifier is named length, we know that. It's resolved to a declaration. That declaration is in the arguments block. Oh. What are the declarations? 20215. I wish the debugger would print this. I guess I could write macros to tell it how, but then I have to update those all the time. So it's function argument or return, that's right. 202 value bake, auto value bake. 1 exported, immutable, value bake is required. Okay. So I'm confused about why we are, all right. Here's the thing. Value bakes were added separately from the original polymorphism, and yeah, okay. I'm just going to fix this with something that's kind of a workaround. Like, really, if we're using this value, we shouldn't be trying to compile this procedure yet, right? Because we don't know the return type yet. Oh. Yeah, so the problem is that the real problem is we're compiling this procedure when we shouldn't be trying to compile it because it's really polymorphic in this. If the $ were on the right, we wouldn't be compiling the procedure, but it's only on the left, right? Like if I do this all of a sudden, this probably works. Let's see. Still, what? What? Really? That's a very spicy meatball. Okay, well, maybe it's easier than I thought then. Okay, why are we here? Oh, because it's in a procedure header. Okay. So let's get the current I'm going to solve this in the way that comes to mind to solve it, which may not be the best way to solve it. Okay, so we can say get current queued, yep, So here, no, here, when we're going to do this, 5645. If, oh, we already have inside polymorphic, we have an inside polymorphic function. Well, if it's not a polymorphic function, then we do this stuff. Okay. We have this no check-in thing now where it'll reject my attempted check-in. Okay, get current queued. Takes the interp. Literal. Okay. How about if we do this? If it's a polymorphic function, yeah, I don't know, something like that. Oh, that's not good. Why'd we crash? All right, because down here we're assuming, yeah, we got to return. Because when I say, so this typedef polyuse thing that I just said to use is not an array type anymore, and down here we're like assuming that we have an array type. I don't know. It's fine. Okay. Yeah. That's a legit thing. So we're going to say cast to U16 of the index. Okay. For a print comma it print new line. So we're going to print all the members of A, because why not? There we go. So this works now, which is good. Does this work? I don't know. Oh, well, not does this work, does this work? It does. Okay, so we do correctly flag it as polymorphic. So now I got to go to my no check-in and explain what the hell I'm doing. Okay, this is a bit of a workaround. Hack would like to find a better way to do it. The deal is, if we are polymorphic, we may Okay, there's a whole underlying situation here. Okay, if a procedure is polymorphic, then maybe I don't do any of this stuff, and I just tell you, hey, it's polymorphic, we don't know what it is, right? The issue with that is that this is a language that's trying to be good about runtime type information. And if something is polymorphic, but we know the types of some of the arguments for sure, then, you know, maybe we should try to report those types, right? So that at compile time, you have more information about what the procedure is, and you're only lacking information about the arguments that we don't know. So that's why we're kind of doing this. But I'm going to factor this around a little bit. Instead of punting way out here, I'm going to finish this comment. So I'm instead going to say, if we can't get a literal, so if we can't get a literal and it's a polymorphic function, then we bail out. We say, if we are polymorphic, we may be trying to use a polymorphic variable in our array dimension. So we don't know how big the array is yet, but we don't want to punt completely on trying to resolve argument types, because if the function is polymorphic only in some argument types or return types, but not in others, we would like to give the compile time metaprogram maximum information about what that procedure is. Maybe this is overkill. I don't know, man. There could be a lot of corner cases to deal with. Okay. I messed something up. Too many closed braces. All right. Let's make the release compiler. Build that, run that. Go over, build that, run that. Oh. What? There's a bug in the tests. All right, we've got a compiler bug of some kind that someone's going to have to track down later. That was, which one was that? It was in, uh-oh. I'm going to have to go back later and look. It was in unions, enum unions something. Enum's union structs. I'm writing that down. Intermittent failure. Compilers are fun. What are people uh-ohing about? Start using Pygame. All right. Yeah. Does this language have any reflection? Yes, it has a great deal of reflection. Depending on what you think reflection means. That's the caveat. What's the difference between unit tests and the test suite you're using? So these are feature tests of the compiler, right? They're things we are running to make sure all the features work. Unit tests would be very different. Unit tests would be in the source code of the compiler itself. We would have a large number of files whose job is to test subroutines of the compiler and make sure they return the right values under various conditions. I think that's not a very efficient way to program. It's a good way, I think, initially to attack a very difficult problem sometimes. Like sometimes if a problem is really hard and you can identify some subfunction that's non-trivial and that might be hard to debug, but that's usable in isolation and makes a lot of sense in isolation, you can write unit tests for that thing. So for example, you're making a compressor and there's like a quantization phase and you want to make sure the quantization is correct. You might write a unit test for quantization or something. I don't know, I don't write compressors. But trying to do that to all parts of a system like a compiler or a game it's an extremely inefficient use of effort because most things don't lend themselves to separation into easily identifiable and testable components that cleanly. And most of the interesting problems in a big system are not limited to the isolated components either anyway. So with the unit testing kind of scheme, you end up writing a large amount of code to test the simpler kinds of problems, and it doesn't even solve your hard problems, right? And then you run out of effort to solve the hard problems because you spent all your effort writing these unit tests. That said, when solving really hard problems that are like systemic level bugs that are behavior that you don't understand because your system is complicated, it is useful to have confidence that your individual pieces are working as expected, right? Because often what happens is one piece isn't quite working. The problem is unit tests don't really solve that either because they can't exhaustively test everything, usually. So you're going to have that subtle kind of bug is going to slip through your unit test anyway because it was some corner case you didn't really think of. That's why it confused you. So I don't think unit testing is particularly valuable unless you're like NASA and you're sending a spaceship to the moon and the amount of money you're willing to spend per line of source code is very high. If that's true, then yeah, do that kind of thing. But for games or even compilers, I don't think unit testing is particularly useful. Like, I don't even know, there aren't that many units in this compiler, right? It's a very integrated program, so I don't know. You recall me saying something about this language having a better alternative to exception handling. Is that the big new feature you talked about? No. No, the alternative is just you return values from procedures. Exception handling in the C++ sense is a very bad idea for imperative languages, and you shouldn't do it, right? The one type of exception that you should have is a panic. I've ranted about this multiple times. Someone could probably link you a YouTube video so I don't have to spend 15 minutes repeating myself. Exception handling in that sense is just bad. If there are bugs in the compiler, doesn't it make the tests unreliable? Yes. What if a compiler bug makes some unit tests give false positive results? Am I overcomplicating? Well, a compiler bug might not make unit tests give false positive results, but it might make that test give false positive results, yes. But that's just, now you're just talking about that software is complicated, right? And you try to get around that by writing as many tests to come at the problem from as many angles as you can. But fundamentally speaking, unless you've done theorem proving on your entire program, you can't ever actually know that a program is correct by any means, right? Ignore whether it's via testing or not. Like, the way that we in reality know programs are correct when we didn't theorem prove them is that we just run them a lot and it looks like they're correct. Like, that sounds irresponsible and stupid and horrible, but that is literally what happens. So when people ship commercial software, they just have people test it a lot. And the tests, the human testers, for example, reveal new bugs and problems, and then you go solve those until they're not there anymore. Or if you're Microsoft, you don't bother solving them. So that's how things happen in reality. And yes, it's an imperfect process. But you know, we as a world have gone away from this anyway. So to tell you how crazy it is now, so systems like Git and backup systems like the one Jeff uses, it does content addressable storage, right? Which means you name your data by hashing the data. And then there's just a hash. And hashes could collide, which would make the system incorrect. But it's like, well, the hash is bigger than the number of particles in the universe, so probably our things don't collide, right? But you're engineering a system that is incorrect. Like, from a pure algorithm sense, it is incorrect. You can't prove that system correct because there's a probability that it'll fail. And you're just saying, well, the probability is really low, so it won't happen, right? Like, the probability is lower than the probability of Earth getting swallowed by a black hole or something. Hopefully, if you design the system well and there aren't any surprises. So lately, in the past decade or so, we've gone in this direction of software that is by design not even correct, except probabilistically, which I find a little bit scary on some level, but that's where we're at. So insisting that somehow everything is guaranteed to be correct, you may not get very far, because theorem proving methods, there's sort of limits that they can't go beyond right now in terms of program complexity. And even if they could, I don't think you would want to write a program in ways that are provable by theorem, because it's very tedious and it would take you a lot more effort than to write a program straightforwardly. And like I said, it may close certain doors to you of techniques that people use. So yeah. So the other difference between unit tests and integration style tests, okay? These tests that we're running here do not have anything to say about the internals of the compiler. They're just programs that we compile and run. And that's part of the purpose. So if I do a massive refactor, if I decide tomorrow, hey, some of the basic data structures for the syntax tree should be totally different, or some of the procedures in the compiler should have totally different arguments or whatever, these tests do not change at all. And I massively refactor the compiler, and I'll probably screw some things up, and some of the tests will say, hey, you screwed this up, and then you fix it, right? That's the value of this kind of test. Unit tests freeze your program in place. They reduce agility because your unit tests are trying to call some API or set up some data structures that your program is using. And anytime you want to change a data structure or an API, there's some amount of inertia, friction, preventing you from making those changes, right? And the higher that friction gets, the less likely you are to make those changes. And if you don't make those changes, that's bad because your code kind of rots or gets messy, right? So the more you have a bunch of redundant, mostly pointless unit tests calling into your API or looking at your data structures, the more it's like a spider web or a glue or something holding you back from making changes, because now you have to change all the code of these tests, right? And that is tedious and annoying, and it slows you down a lot, right? So that's what I don't like about that kind of test. The smaller the number of lines of code are that need to be changed for any given code factor that you want to do, the better and the more agile you are, right? And those tests just slow you down hugely. So I don't like them. I really don't like them in general. Unless, there are a small number of relatively high-level tests that don't need to assume a lot about the structure of the program. Then they're fine. What kind of network security things did we have in that multiplayer tank game? None, almost. It was a very different time. We did not really worry about... There were hardly any networked games at that time. It was 1996, okay? We didn't worry about network security in 1996. Nobody ever encrypted anything. Nobody ever signed and hashed anything. Yeah. There was no such thing as HTTPS, I'm pretty sure. Like, just forget it. Yeah, you could classify these as regression tests, except, yeah, I don't know. I mean, I don't get that picky about testing terminology. Okay. Well, we fixed a bug, sort of. I think we're going to have similar problems with other things. Like, for example, if I want to try to guess something else. So the problem with this solution is I only solved this for array dimensions, right? And anything else that needs a constant expression, anything else that needs a constant expression, it needs to have similar logic. And I'm not sure I see a way around that. So if I was going to make something, I'm not going to fix this right now if it breaks, and I think it'll break. I'll just make a note about it for later. What was our thing called? Test? Yeah. So if I want to make something else that'll break in a similar way, I could say like h, and instead of using length here, if I just say well, let's go back to this one. Like, what if I do that, right? Because we just said type of wants a constant. Maybe it'll work. Oh, wait. We don't want to return. . don't want to return T because T is not. We want to return something of type of length. I'm going to say other is a T, and we're going to return other. We could return length. Anyway. Oh, wrong folder. Whoa! That's, okay, that's bad enough. We have to fix that, because that's a compile crash. Well, you're seeing why we haven't released things to the public yet. Unhandled type in translate type, really? For the $T, how is that possible? Like, I literally don't know how this is possible. Let's find out. I knew it would break, but I didn't think it would break that bad. What is our type? Flags are 100. Type info in progress. Oh, man. Okay. I'm just going to make this one an internal compiler error for now, so that we don't crash. Well, we should at least do that, and then maybe we'll continue to debug it a little bit. So we are in line 1008 of type table. So if, well, we'll make this an internal compiler error too. So here is, instead of a warning, this is an error now. I made this a warning a long time ago because it was like, well, we're not done. But now everything should be going. This whole file is the thing that makes the type infos that your program can use for introspection, right? And so at this point, that's supposed to work. So this is now an error, internal compiler error. And the fact that we reported an error should cause the rest of the program to stop and not continue after this point, right? So if defen flags and in progress, we're just being more specific about it. Attempt to what's this procedure called? It's called export, right? Attempt to call translate type on a type that is in progress. Sigh. Okay. Yeah. So we have a more specific error now. We'll commit that. Okay. So now the question is, why is that in progress? And I think the answer is well, I don't know. It's worth at least investigating. We're here now. Okay. Attempt to call translate type on a type that is in progress. It is here. It is the type of an expression. Oh, we're just going through the flatten loop. Line 88. Ha 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 ha. 88. It's a type definition. Wait, what? Well, is that type def type? Terp type def type. Yeah, okay, so this is a thing. It was copied from a polys. Really? Oh, it was copied because yesterday we did this thing where we copy. We copy and then infer. Okay. We copy, we remove the dollar signs, and we infer. That's what we added yesterday for typos. So I think there's a problem with the new thing that we did. Oh, but we only removed the dollar signs here, so that's fine. There's no dollar signs. It's the infer step. So we were copied from polysource. What is this? Yeah, so that's the thing that defines T. This is where it gets a little confusing. I still have a hard time thinking about this stuff. Let's convert this to a type definition. Ugh, mistype. All right, let's see when this gets constructed. Okay, so first of all, let's make sure this number stays the same. 7534. Right. X for S, 7534. Okay, so where does that get created? Probably in copy. Ah, I hate this new UI so much. Your procedure signature syntax does annoy me because it's ambiguous. To make it unambiguous, make sure, no, it's not ambiguous. It's not ambiguous, it just has a certain precedence to it. I may or may not put parentheses there, but that has nothing to do with whether it's ambiguous or not. The ambiguity is, like you can say if then else in C is ambiguous, but no, it's not. You just have a convention for what it means when you do that, right? Or if, so the thing in C is you say if something else something, right? Where does the else go? Oh my God, it's ambiguous. And it's like, no, it's not. It's just, you decide what that is. And it's a rare enough case that it doesn't really matter anyway, right? Same thing here. You decide if you put, the only cases where that would happen right now are in literals and passing a thing as an argument to a procedure, and in either of those cases, you just decide what the comma means, and you're good. It's fine. That's, programming languages are like that. It is ambiguous. Explain to me what this would be. Int or int arrow int is the first an int or a procedure that takes int. And the second one, is that a procedure that returns an int or a procedure that takes an int? No, it's the same thing. It's not ambiguous. It's that there's a decision about what those mean in different contexts, right? I mean, there's a potential ambiguity if you didn't make that decision, but the decision is made in a way that does what you want most of the time, right? Yeah. That said, again, the reason I'm not rat-holing on this stuff is the syntax is probably going to change completely. So the reason why I don't care about any of this stuff is because you can spend a long time digging into it, and then it didn't matter because it all changed. So yeah, I'm not worried about it. All right. Well, here's where we create that type definition. We are copying another type definition. In here. So like I said, this is the code we added yesterday. And there's a little bit of brand new trouble in River City happening here. But it's good because we have that clear $signs variable set. So we know. So source has is constants block entry for polymorph type variable. Okay, so here's what we're going to do. If clear $signs, if source is constants block entry for polymorph type variable, return interrupt type def poly use. I think that's right. I think that's right. I don't know. Sometimes I don't know what I'm doing. In fact, a lot of the times I don't know what I'm doing. Hey, look, it works. Well, let's now, we really should call the procedure. Let's move it down here because all this stuff is something else. So that's our thing. So I'm going to say a comma b colon equals, wait, we already used a, x comma y colon equals hh of, let's say len is a U8 that's 33. So we're going to say HH of len, right? Not U. Y is whatever. All right. X is U16, Y is 0. Why is Y 0? That's not right. Okay. Yeah, we returned the wrong thing. We don't want to return. I think we want to do something slightly different here. It's good progress, though. It's good progress. Let's actually make sure that we're breaking in the right place. And because Visual Studio is terrible, we can't just set the breakpoint out there as far as I know. Okay. Maybe you can, and I just can't figure out how to do it because it's so crammed full of other useless things that I don't care about, making it complicated. So what are we copying? We're just copying result. Result is already a type definition. Yeah. Wait, why are we force inferring a type definition? That doesn't make any sense. What was I smoking last night? Oh, because it could be a procedure. Yeah, never mind. Could be a procedure type definition. Okay, so if we're doing clear dollar signs, I was smoking the right thing last night, apparently. I don't smoke, but you know. Okay. When we see a type definition that defines so we affected the inst before, and we said, oh, that'll affect the type definition also, which is true unless it's the top level type definition, in which case it won't. So in that case, we need to say I think we just don't do all this in that case, actually. I think we just leave it. So I think we don't do this. Can't believe they haven't fixed some of this stuff. Gee, you're so helpful of you typing the close comment to force me to delete the close comment you just inserted. That's why I don't use Visual Studio to edit. All right, so in Typer, when we say clear $signs, we're only going to do that if oh wait, it's still 0. Why is it 0? This is like a serious problem that I don't understand then. We didn't even do the thing. We didn't even kick in our new thing. Okay, let's simplify the example, by the way. Make it easier to think about. And we'll make Ginger Bill happy by putting a parenthesis here. Whoops. I want this set up. So I want this setup here where length is a U8 that's 33 long, and I'm going to say x is HH of len. Yeah. Oh wait, this is right. Duh, it's correct. What am I talking about? It is of course 0. I hope somebody got me in the chat. Yeah, yeah. No, this is a 0. I'm just stupid. I kept thinking, oh, it's a type, but it's not a type. It's a value of that type. So other equals 5. Now we'll get 5. Sorry, guys. This is what happens when I don't sleep enough before Super Stream Sunday. You know what I'm saying? So let's go back. I actually liked my other solution better for this. And I will say clear $signs is intended for procedure types with deeply nested $signs. Usually it changes the type inst, but in the case where the root passed into copy, for example, the axis type of x is itself a $sign variable, we won't have an inst since it got substituted already. So, well, I could just we won't have an inst since it is an expression itself. Wow, I need to sleep more before Superstream Sunday. All right. I think we're coming up on a break here from you. We've been streaming like for more than 3 hours. So we'll take a break. Oh, before, well, no check-in. There we go. I left it in the comment. I knew that happened when I did it, but then I forgot again. All right, it was irresponsible to type that check-in command without testing anyway. So we're testing. Testing here. Yeah. We're testing this. Yeah, all right. Okay, we're now going to take a break. I'm not sure when we'll pick up. Maybe in half an hour, maybe in an hour. It's Superstream Sunday, so we got to be streaming until late at night. We'll do more compiler work. And yeah. Thanks for stopping by so far, and we'll pick it up soon.